Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Hayal Sibai. I am a member of Faculty of Engineering Technology. I'm glad here today to be part of this course, the Mooc course, which is titled Circuit Analysis Power Consumption. Actually, I am here with you to present the module 10, which is going to be divided to 3 parts. We will start with part 1. Module 10 is actually an introduction to basic of AC fundamentals. In this part, by the end of this part, you are going to be familiar with how to generate the AC voltage. Also, you will understand the voltage and current convention for AC. So the start of this one actually is we need to start with the application of electromagnetism. I think in the electrical fundamentals, if you study electrical fundamentals, you should be familiar with the application of electromagnetism. So there are 2 main applications for electromagnetism. There are 2 main applications for electromagnetism. First one is an electrical generator, which is used to create electricity from magnet and movement. The other one is the electrical motor, which create mechanical movement from electricity and magnetism. So today we are going to focus on the first one, which is electrical generator. So let's start with the basics of magnetism. As you know, a magnetic field creates from flowing electrons. So if we have a wire, an electron by electricity is flowing through it. So that means, as you can see here, that it will generate a magnet field. This magnet field is visible if you use iron filling. If you put the wire and the paper, then you throw the iron filling, you can see these lines of the field. Actually, there's also what's called the induced current. The magnetic field can be used to produce electric current and voltage. If we have a magnet, then this magnet is moving into a coil of wire that is part of a circuit. A current is produced or induced in the wire. If we change the direction, that means if the magnet moved out of the coil, or if we change the poles of the magnet, that means the opposite pole of the magnet is moved into the coil, the direction of the induced current is reversed. Actually, moving the magnet or the wire will induce this electricity. So alternatively, a current can be induced in the wire by moving the wire at right angles across the magnetic field. And I highlight the word angle because it's important, as we are going to see. So a voltage is produced between the ends of the wire when the wire or coils cut through the magnetic field lines. The induced voltage causes current to flow through the wire. And the wire can be more than one wire. In other words, it's a coil. The size of this induced voltage of current actually depends on 4 elements. The first one is the speed of the movement. So when the speed of the movement is increased, the size of the induced voltage is increased. The second one is the strength of the magnetic field. The third one is the number of turns of the coil. And the fourth one is the rate at which flux lines are cut. In other words, is the angle. Because changing the angle will change the rate of cutting the magnetic field lines. Now, the application of this, instead of moving the wire, as you can see here in the figure, actually we rotate an coil. Okay, so rotating the coil is similar to moving the wire. As you can see, producing an electricity in the coil. I actually prepared a video. Actually, if you look on the YouTube, looking for the keyword generating DC or AC voltage, you can see many videos explaining the principle. So actually, one of them is the video that I prepared for you here. You can find the link and you can see this video here. Okay. After seeing this video, I think you are now familiar with the principle of generating the electricity using the rotating coil, and you understand why I highlight the word angles. Okay, so as you see, from rotating the coil using two rings, as you can see here, the resulting voltage is proportional to the rate at which flux lines are cut according to the Faraday's law, and its polarity is dependent on the direction the coil sides move through the fields. So as you can see in figure A, when angle is 0° position, there is no current. In position 90, we have the current is flowing in one direction. Going back to position 180, it's reduced again to 0. And going back to D, looking at the figure D, you can see that at the position 270, angle 270, again we have it's perpendicular, so it's like the maximum, and but it's the opposite direction. So the result of this operation is actually having a sinusoidal waveform, starting from angle 0, increasing to maximum voltage at angle 90, decreasing back at angle 180 to 0, then increasing to at angle 270 to maximum, but in opposite direction, we can say it's negative direction, and then going back to 0 at the angle 360. This is one cycle. So one cycle will perform one waveform. Of course, completing the cycles will introduce, as you can see here, the continuous waveform. Okay, it's a continuous stream of cycles will make a continuous sinusoidal waveform. This is one way of generating AC. Another way of generating the AC is using what's called the AC function generator. If you attend the lab, I think you're already familiar with this. This one is not using the rotator, it's using an oscillator inside this function generator, or other words of it is signal generator, which is produce the repetitive wave. Using this generator, actually you are able to set the frequency and amplitude of the signal from the signal generator. Now, just final thing we need to discuss in this part is as you can see here in the figure, this is the DC. In DC, we have the conventional direction of the current, which is from the positive pole of the battery to the negative one, and it's steady all the time. It's one direction. So here in this graph, you can see the current and the voltage. They are always in one positive or negative according. And if the current is in the direction of from positive pole of the battery to the negative pole, it's always positive. The same is applied in AC, alternative currents. Although there's actually not really negative and positive, because it's like kind of vibrating. But we can take one direction as positive, the opposite direction as negative. So when we draw the circuit, as you see, we put as you can see, we put the positive and negative. So the current is, if it's in this conventional direction, we consider it as positive. If it's opposite to it, we consider it as negative. So as you can see here, for the sinusoidal waveform, its half is positive and its second half is negative. So like this, we reach the end of this part. In this part, I introduced to you the concepts of how to generate the AC voltage, and we understand the voltage and current conventions for the alternative currents or AC. Thank you very much. And here you can see some references that you can go through if you are interested to learn more about this topic. Thank you very much.